Hi, this is Mrs. Nearing, and in this video, we're going to talk through the analysis of brass lab. And our goal in this lab was to figure out how much copper is in a sample of brass. So our end calculation is going to give us a mass percent. So we'll be able to say, okay, this sample of brass, it is 10% copper, it is 20% copper, is it 30% copper? That's what we're trying to find out. So in this lab, we're using spectrophotometry, in which basically you're shining a light at a sample and you're observing how much of the light passes through the sample versus how much of it is absorbed by the sample. And this will produce a reading, which is called the absorbance. So the absorbance has to do with how much light's being absorbed by your sample. And there's a mathematical relationship between the absorbance and the concentration, and it's called the Beer-Lambert law. So this is where A right here is absorbance. Absorbance is a unitless number. There's no units there. And then C is concentration, and we typically measure concentration in molarity. So as the solution becomes more concentrated, the absorbance is going to increase. So there's a direct relationship there. Step one before we can use our spectrophotometer for this lab is we have to figure out what wavelength of light our solution will absorb well, because different colors of solution will absorb different wavelengths of light. So we set up an experiment where we took a copper solution, which is blue, so aqueous copper ions are blue, and we put them in our spectrophotometer and measured absorbance versus wavelength. And we'll notice here that our blue solution absorbed really well right here in this region. And when we looked at it in more detail, that was at around 630 nanometers. And that turns out to be orange light. So it turns out a blue solution absorbs orange light really well, and that's about 630 nanometers. So then our next step is we set our machine at 630 nanometers. So we set this fixed wavelength. And then we started making a graph where we're plotting absorbance at 630 nanometers versus concentration. In order to do that, we had to make solutions with a variety of concentrations. So each person made a dilution. Maybe you made 0.2 molar, 0.3 molar, 0.1 molar. And then we measured the absorbance of those solutions in order to get a graph. So we're graphing absorbance versus concentration. It should be a nice linear graph. And so far we're just dealing with our copper solutions. Now let's talk about the actual brass itself. So we weighed a small sample of brass, and then we dissolved it in nitric acid, and then we measured the absorbance. Well, first we diluted it then to a set volume. So we took our sample and we diluted it to exactly 100 milliliters, and then we measured the absorbance of this brass solution. Okay, so what we did just now, notice how we took this solid sample of brass that looks like this, and we turned it into this blue solution that we can measure the absorbance of. So now let's take a look at what we can do with this information now. So how are we going to use this data to find the mass percent of copper? So the first thing we want to do is we want to find the concentration of copper in our brass sample. So we're going to use the slope of that line to find the concentration of our brass solution. So remember, we made this graph, absorbance versus concentration, and we found the slope of it. So now we're going to use that. So let's look at this sample set of data. For this data set, they found that the slope of this line was 2.818. So we can write this in the equation y equals 2.8 times x. And if you think about what y is our y-axis is absorbance. Okay, so absorbance equals 2.8. I'm just going to round it to 2.8 to make it easier, times the concentration. And let's say that we took our brass measurements, and let's say with our sample of brass, let's assume that we had a 2-gram sample of brass, and then when we diluted it, we dissolved it and diluted it to 100 mils volume, we measured the absorbance was 0.3. That's the absorbance. Absorbance is unitless, so there's no units to that number, it's just 0.3. So let's say so we know the absorbance, so now we should be able to figure out what the concentration is, because we know here the relationship between absorbance and concentration. So to solve for concentration, we're going to rearrange this and solve for x, which is our concentrations. We're going to say x is, y divided by 2.8. So our concentration is going to be our absorbance, which is, 0.3 divided by our slope. So that's another way of saying this, right? Absorbance is slope times concentration. So concentration is going to be absorbance divided by the slope. I'm just rearranging and solving for x. And when I do that, you can stop and plug it in your calculator and you will get an answer. In this case, I find that my concentration is 0.10. Well, let's keep all our sig figs here. Okay, so my concentration is about 0.1 molar. So what this means is, let's go back and again think about what this means, is I took my brass sample, I dissolved it in nitric acid, okay, I made a blue solution that had a volume of 100 milliliters, and we took the absorbance of the solution, and that told us that the concentration of copper ions in that solution is 0.107 molar. That's what we've figured out so far. All right, so let's go on to step 2. Now I'm going to find the moles of copper. So again, let's summarize what we know so far. We know that our solution had an absorbance of 0.3. And from that, we were able to figure out the concentration was 0.107 molar, as we figured out over here using our graph. And then we know the volume is exactly 100 milliliters. I know that because we're the ones that made the solution and we diluted it to exactly that volume. So if we want to find moles, let's take a look at this equation right here, which shows us what molarity is. So molarity is the moles divided by the liters. So we know the molarity is 0.107. We know the volume, we have to convert that into liters. So the 1 liter is 1,000 milliliters. So 100 milliliters is 0.10 liters. Okay. So there we go. That's our volume is 0.1 liters. And then this on the top is our unknown. So if we know the molarity and the volume, we should be able to find moles. Okay, that's step 2. We'll find moles. Step 3 is once we have moles, we're going to convert it into grams. And then we know how to do that, right? We've done that several times. Moles times molar mass is going to give us the mass. So moles times the grams per mole is going to give us the grams. So we're going to look on the periodic table. We're going to look up what the molar mass of copper is on the periodic table, and we're going to use that. If you look on the periodic table, you'll see that copper has a molar mass of 63.55. Remember, that's the number there on the bottom. That is the molar mass. Okay. So now at this point, you will have found your grams of copper. And then the last stage, you're trying to find the mass percent of copper. And just in general, remember, a mass percent is just mass of the part divided by the mass of the whole thing. So if we're trying to find the mass percent of copper in brass, we would take the mass of the copper, which we just found out over here, divided by the mass of the entire brass sample, which you weighed out in the lab. Okay, so again, if we kind of think this through, the brass sample, this you took the mass of directly in the lab. So it's maybe somewhere between like 1 to 2 grams-ish. You have the exact data written down in your data table. And the mass of the copper you found using the absorbance. So the absorbance gave you the concentration. And then once you knew the concentration, we found moles. And then once you know moles, you can use the molar mass to find grams. So those previous steps we just took, that gave us the mass of the copper. Divided by the mass of your whole sample, you're going to end up with a percentage. And for our lab, your percentage should be roughly, probably between 20 to 50% is where you should be ending up, somewhere in that range for your mass percent of copper. And that is it for your calculations. Let me know if you have any questions.
Yes.